Let's explain the type error object of type bytes is not JSON serializable error in Python. This error pops up when you try to convert a Python object into a JSON, JavaScript object notation string, but one of the objects within is of the bytes type, which JSON doesn't directly understand. JSON works with strings, numbers, booleans, lists, and dictionaries, not raw byte data. To fix this, you need to convert the bytes object into a format JSON can handle, typically a string. Here's how. 1. Identifying the culprit. First, find out where the bytes object is coming from. Carefully examine the code that's causing the error. The error message usually points to the line number. Often, it's within a dictionary or list that you're trying to serialize. 2. Using decode for text data. If your bytes object represents text data, like something read from a file, the simplest solution is using the decode method. This converts the bytes into a string using a specified encoding, like UTF-8, which is common. For example, if you have byte_data =b hello world, and you do text_data =byte_data dot decode UTF-8, which would give you text_data hello world, then include text_data in your JSON structure instead of byte_data. 3. Base 64. Encoding for binary data. If your bytes object represents binary data, like an image or audio file, decode isn't suitable. Instead, use base 64 encoding to convert the bytes into a string representation that JSON can handle. The base 64 module in Python does this. You encode the bytes and then decode it when you need the original bytes again. For example, Python import base 64 byte_data $x00x01/x02 hash. Example binary data encoded _string =base 64.b64 encode byte data decode UTF-8 hash encode and decode to string hash. Use encoded _string in your JSON. Decoded _bytes =base 64.b64 decode encoded _string dot encode UTF-8 hash. Decode from string back to bytes when needed. 4. Handling nested structures. Sometimes the bytes object is nested inside a larger structure like a list or dictionary. You'll need to recursively apply the above methods. This may mean writing a function that iterates through the structure, checking each element for bytes type and converting it appropriately. 5. Example scenario. Imagine you're processing data from a file and trying to create a JSON representation. Python import JSON import base 64 with open myfile.bin rb as f binary_data =f.read hash. This is a bytes object, data name, myfile, data, base 64.b64 encode, binary data, .decode, UTF-8 hash, correctly encodes binary data. JSON_string JSON.dumps data indent $4 print JSON string. Remember always to carefully consider whether your bytes data represents text or binary information, and use the appropriate conversion method. Carefully checking data types before JSON serialization is key to avoiding this